video will show you a simple, systematic 4-step approach to solving mathematical questions. These are often referred to as problems in mathematics. This approach can be applied to many different types of questions. The 4 steps are: Step 1, understand the question. Understand precisely what the question is asking and identify the key pieces of information given in the question that will allow you to achieve this. Step 2, develop a plan to solve the question. Step 3, carry out the plan. Step 4, reality check. Make sure that your answer makes sense within the context of the question. Step 1, understand the question. In this example, we will be answering the question, how many squares of any size are there in a chessboard? So let's look at a chessboard. What does this question mean? Obviously, there's a square, but the question says of any size. So there are more squares here than the obvious small ones. Well, there's this 2x2 square, and there's also this 3x3 square. We need to also consider that these squares are going to overlap, like this one here, or this one. So what the question is really asking is how many squares of all these different sizes are there in total? Step 2, develop a plan. To create a plan, we need to ask ourselves several questions. The first question is, what information has the question provided? We also need to ask ourselves, what does the question require us to determine or provide? In this question, that is obvious. What is the total number of squares? The third part is the harder part. How do we get from one to the other? That is what the plan involves, figuring out how to get from what has been provided to what we've been asked to determine. We could try and use a systematic counting system like this, but is that the best way? Maybe we could look at how many there are across and then how many there are down, and use this to simplify the question. As we know, there are 8 squares across and 8 squares down. This gives us 64 of the smallest 1x1 squares. We could use this as our method and try and expand this to the larger squares as a method of solving the question. Now that we have a plan in mind, we can continue to step 3, carry out the plan. Remember that, for the 1x1 squares, we can fit 8 across and 8 down for 64 squares. So let's give it a go for the 2x2 squares. As we can see, there are 1, 2, 3, 4, 5, 6, 7 of the 2x2 squares across the top and 7 squares down, giving us 49 of these 2x2 squares. Moving up to the 3x3 squares, we can fit 6 across and 6 down. So we can see that as our square size increases, the number we can fit across and down decreases. So we can fill in the rest for the larger squares, including the whole chessboard as one square. Add it all together, and we get 204 squares in total. Now that we have an answer, we need to ask ourselves, is the answer reasonable? In step 4, the reality check. We need to ask ourselves, what is a reasonable number of squares, and what answers are completely unreasonable? For instance, if we got a negative number as our answer, like minus 76, is that reasonable? What about 21 3/4? Depending on the question, there are other ways we may catch a mistake. Like for instance, if we found there to be more of the larger squares than the smaller ones, or perhaps we can see an obvious square that our plan is missing. All of these are ways in which we can hopefully catch mistakes and go back and find out what went wrong before submitting an incorrect answer. And that is our 4-step problem-solving method. It should come in handy for any mathematical questions you encounter.